Welcome to day 2 notes. We're going to be talking about the rectangular coordinate system today. It's going to be review of stuff you've taken in other math classes previously, so hopefully there's nothing too new here. So let's just jump right in. The rectangular coordinate system, or the Cartesian coordinate system, uses the ordered pair x, y. X comes first. It tells us how far left or right of the origin we are. The y tells us how far up or down from the origin we are. Positive x is to the right, negative is to the left. Positive y is up, negative y is down. And we always start counting from the origin where the x and y axes meet. So you should already be able to graph lines, circles, and parabolas. So we're going to do a couple quick refreshers for those. If you're given a line in slope-intercept form, y equals mx plus b, your slope is right there. Your b, which is your y-intercept, keeps that sign. So our y-intercept is 3 below the origin, and our slope is 2, or 2 over 1, which is the same thing as negative 2 over negative 1. So from this intercept, I can count up to right 1, up to right 1, or I could have counted down to left 1, down to left 1. In Algebra 1, when you started doing lines, they made you always put 5 dots. In geometry, they said 2 dots make a line. The more dots you have, the easier it is to sketch a straight line, and counting to 2 is not that difficult, so I would recommend putting more dots than less dots in an example like that. For the second one, we are going to be using intercepts. So for intercepts, you treat each one of these variables as if they're 0, and what does the other one have to be? So right away, if x is 0, I have minus 5y equals 10. Minus 5y times negative 2 equals positive 10. So when x is 0 to the left or right, I have to go down 2. Okay, and then I'd repeat. If y is 0, then I've got 2x equals 10. 2 times 5 equals 10. So I go 1, 2, 3, 4, 5 spots to the right, and I connect those dots. Okay. These ones are ones that students struggle with a lot. If it says x equals 3, it means x always equals 3. It does not care what y is. Y can go up or down as far as it wants to. It is a vertical line. X always equals 3. Similarly, if y equals negative 5, 1, 2, 3, 4, 5 down. That's a horrible line. I'll try to draw it on that one again. It's always going to be negative 5. It does not care what x is. It can go left to infinity or right to infinity. As a reminder with these videos, feel free to pause and rewind if you feel like I'm going too fast. So then in Algebra 1, you started graphing vertex form. I'm sure you did that in Algebra 2 a little bit as well. But a quick recap, we've got a times the quantity x minus h squared plus k, where hk is the ordered pair of our vertex. Notice it's minus h here, but a plus h there. So it's the opposite sign. And then the a is the vertical stretch. Okay, parabolas are symmetric, so if you can find any points to the right of that vertex, you should be able to find ones to the left. And the parent function is y equals x squared. So we're going to be using this table over here when we are using vertex form. You might have seen it with, instead of a y there, an x squared and then an ax squared. It kind of depends on who your teacher is, but we'll see how this kind of works again in these examples. So for this first one, my hk is where I always try to start. My h is 2, and there is no k. So 2, 0 is my ordered pair of my vertex. Now, for that table, we're at x, y, ay. I can pick any number x that I want. I'm going to avoid 0 because that's not going to do anything for me, but I'm going to pick 1. And what we're doing is pretending this vertex is our origin. So if I go 1 spot to the right, 1 squared is 1, and then my a value is also 1. So I'm going to go to the right 1 and up 1. If I would have gone to the left 1, negative 1 squared would still be 1, times 1 is still 1. Okay, that's very close points. Let's pick something a little bit further out this time. Let's pick 3. If I go 3 spots to the right, 3 times 3, because we're doing x squared, is 9. Our a value is still 1, so it's a 9 there. So from that vertex, I go 1, 2, 3 spots to the right. I go 1, 2, 3, 4, 5, 6, 7, 8, 9 spots up. That goes off the graph, so it's not the best point to pick. Okay, so if I would have done 2 instead, 2 squared is 4. Okay, so I go up 1, 2, 3, 4, or I could have gone left 2 and up 4. Gives me my parabola there. Now if you notice, since our a value is 1, this column is entirely worthless to us. It doesn't help us at all, but it's going to be a lot more helpful in this next example. So in this next example, our hk is going to be -2, +4. Because remember, x minus h, since this is a plus sign, it's the opposite of that 2. So I get -2, and then +1, 2, 3, 4. That's where our vertex is. Now our table is going to be a lot more important. Okay, so instead of ay, I'm going to write 1/4 y. So 1/4 of whatever we get in this y column. If I pick 1 for my x, keeping it close, 1 squared is 1, but 1/4 times 1 is 1/4. I do not want to have to try to graph 1/4 on one of these graphs. So what I want to do is pick numbers so that when I get my y, it is a multiple of 4. Okay, so if I picked x equals 2, 2 squared is 4. 4 times 1/4 is 1. So I could have gone 2 to the right and up 1. And if I would have put in a -2, I would get the exact same 4 and 1. Now I'm going to skip picking 3 because 3 is not going to give me a multiple of 4. But if I put in 4, 4 squared is 16. 16 times 1/4 is 4. Same thing if I had done -4. So from that vertex, if I had gone 4 to the right or left, I would have to go up 1, 2, 3, 4 spots. So I've got my parabola right there. This time that AY column was a lot more useful. All right. Next is going to be circles from geometry. Standard form of the circle is right there for us. HK is, again, very important. We have positive h and positive k for the center of the circle, but in the equation we had minus signs, and then that equation says r squared. Too many of us in the past have just decided that was r, so you got to be careful on those. So let's graph a couple of circles. So very first one is the easiest example. What are h and k? Well, I have nothing being added or subtracted to either the x or the y, so that means hk is 0, 0. That is my origin. 36 equals r squared. I want to know what r is, so I take the square root of both sides. It would be plus or minus 6, but again, you can't have a negative distance technically. So what we're going to do is just count 6 in each direction from that center point. So 6 to the right and left and up and down. Okay, I have those 4 points, and those are all the points I'm going to use. I could try to count a point out here, but I can't just count 1, 2, 3, 4, 5, 6. Okay, so I need to have those 4 points and then do my best to draw a circle. You can try to do it in one fluid motion, or I usually like to kind of do one section at a time. That was a really bad portion. What's really nice about using the iPads, if you go one section at a time, you can delete an entire section without having to erase a whole bunch. I don't expect perfection on drawing circles. If I can't draw a perfect circle, I shouldn't expect you to, but try to make it at least round. On this next one, our HK, our center, okay, that's going to be at 2, 0. So 2, 0, 2 to the right, 0 up is our center. 9 equals r squared. So I've got plus or minus 3 for my r. So 1, 2, 3 to the right and left and straight up and straight down. These smaller ones, maybe you can get away with drawing a circle in one go. I tend to struggle with that myself, so even on the smaller ones, I try to break it up into little bitty pieces. Okay, that was a weird squiggle at the end there. Okay, so that's drawing a circle. Finding the intersection of a system on a graph, it's really easy. It's what point is on both things. Now, if we've got a line and a circle, It's going to be able to intersect once or twice depending on if that line is going to be tangent or not. Okay, so we have to be careful of what we're doing. It'd be really easy to use our elimination methods if we had x squared, y squared in both places, or xy in both places, but we don't. So what we're going to do is we're going to take that first equation of a line and solve for one of the variables. I'm going to take in, say, x equals y plus 6. Okay, if I add y to both sides. And then I'm going to take that and replace it in that second equation. So I'm going to have y plus 6 squared plus y squared equals 36. Okay, then I need a FOIL. Y plus 6 squared. Remember, y plus 6 squared is y plus 6 times y plus 6. And you have to use your FOIL first, outside, inside, last. I'll give you y squared plus 6y is 12y plus 36 plus y squared equals 36. This piece right there is just that y plus 6 squared after I've FOILed. All right, I'm going to combine like terms on this left side. So I've got 2y squared plus 12y plus 36 equals 36. If I subtract 36 from both sides, I've got 2y squared plus 12y equals 0. Okay, I can factor this to 2y times y plus 6 equals 0. So I have two possible solutions for y. So if 2y equals 0, oops, helps if you put the things in the right order, I suppose, or y plus 6 equals 0. Okay, so if 2y equals 0, that means y has to equal 0. So to solve for what x is, I'm going to take this and plug it into this first equation. You can plug it into the original one too if that makes your life a little bit easier. So I would have x equals 0 plus 6, which is 6. So I have one solution that is 6, 0. Make sure that we found x second, but that is the first part of the ordered pair. If x plus 6 equals 0, not x plus 6, sorry, if y plus 6 equals 0, that means y equals negative 6. So I would have x equal negative 6 plus 6, which is 0. So I would have 6, 0 as one solution, and 0, negative 6 as the other solution. Okay, that's saying, like, I'm not going to draw this to scale, but I had a circle, and a line went through it and touched at two spots. Okay, if you remember from geometry, that's called a secant. So for the distance formula, students sometimes like to freak out about this because it's so long, but if you remember your Pythagorean theorem, it's the exact same thing. You have to decide which ordered pair is x1, y1, and which one is x2, y2. Ultimately, does not matter as long as you have 1 and 1 and 2 and 2 together. So in this case, my distance equals the square root of 4 minus 8 squared plus 7 minus 1 squared. Make sure you have those parentheses in the right spot. So 4 minus 8, that's negative 4 squared. 7 minus 1 is 6 squared. So I've got square root of 16 plus 36, which is the square root of 52. Now, if that was like square root of 25, you would know that it was 5, positive 5. But it's not that simple because 52 is not a perfect square number. So this is where you can use your factor trees. I know that 2 and 26 go into 52, and 26 is 2 and 13. So I have a 2 that breaks out. So this is the same thing as 2 square root of 13. Right? Technically, there's a plus or minus if we were just trying to solve the square root here, but I'm looking for a distance, and again, distance is always going to be positive. All right, so now we're going to start talking about angles in their standard position. So if the vertex is always going to be at the origin, and we always have the initial or starting side going this way, trying to make it so you can see it a little bit nicer. It's the positive part of the x-axis. That's always where we start. The quadrant in which the terminal side or the other side falls is said to be the quadrant the angle falls in. So I've got quadrant 1, 2, 3, and 4. So two angles in standard position with the same terminal side are called coterminal angles. So if I want to draw 315 degrees, okay, I start here. and then we always go counterclockwise for the positive, and I just treat each one of these quadrants as 90 degrees. How many do I need to get to? Because we're just going to be sketching. So if I go to this one, that's 90, then that's another 90, that's 180. So the third one is 270, so it's in this next spot. So I'm going to say I started here and went all the way around 315 degrees. Or you could say that you started here, went this way, negative 45 degrees. They're the same thing. It's just two different ways to get to the same place. So for these ones, we're going to sketch it and then do each of those 5 things. Okay, well, each of the 4 other things. So sketch the angle in standard position. We always start right there. We want to go negative 135 degrees. So I can still count that 90 method. To go the opposite direction would have been 180, so we're a little bit less than that. So we're going to be over here. So I went this way, negative 135 degrees. Okay, the quadrant the angle falls in, that's going to be quadrant 3. And name 2 other coterminal angles, one positive, one negative. Okay, one of those 2 is always going to be really easy to get. Kind of ignore the negative part, and what would I have to do to get to 360? All right, so 360 minus 135, that's going to be 225 degrees. Positive 225 degrees and negative 135 degrees are going to be coterminal. Okay, to get another negative 1, that's where we kind of just redo the entire thing and go all the way around and then start again. So that would be negative 135 plus 360. Okay, but I want it to be a negative, right, because it says it has to be another negative, so I'm just going to add a negative 360. Okay, that's going all the way around clockwise instead of counterclockwise. So that would be 5, 9, 4. Negative 495 degrees is another negative coterminal angle. Now finding a point on the terminal side, this is a little bit more challenging. We've got some nice angles here to make it a little bit easier, but what we're doing is figuring out what this line would be of this terminal side. Okay, I know that it's going to be y equals x. The reason I know that is this would have made 180 degrees with that initial side. We went 135. That means this angle right here is 45 degrees. That's called a reference angle. You don't need to know what that is yet, so don't worry about it. But I know that's 45 degrees, which tells me it has to be y equals x because of our 45, 45, 90 special right triangles. So I need an x and y point that are equal. So I'll pick 2, 2. You could pick whatever you want. Find the distance from the origin to that point, 2, 2. Origin is 0, 0, so I've got 2 minus 0 squared plus 2 minus 0 squared. So my distance equals the square root of 8. I don't know why I wrote 2 equal signs there, which is the exact same thing as 2 square root of 2. All right, again, if I went too fast, definitely rewind, pause, and then if you still have questions, ask those in class when you get there. So the next one is going to be the exact same idea, a little bit faster, a little bit easier. So sketch the angle. Hopefully everybody knows what a 45-degree angle kind of looks like. Doesn't get to 90. So we went 45 degrees this way. That's in quadrant 1. 2 other coterminal angles, one positive, one negative. I'm going to get the negative one out of the way right away. 360 minus 45. Okay. That would have been a 315-degree angle, but now it's negative because I went clockwise instead of counterclockwise. Okay, 315 and 45 together make 360, and the negative just tells us which direction. Okay, if I want a positive one, I'm just going to add 360 to 45. I don't have to worry about any signs. That's going to give me 405 degrees, 360 plus 45. Okay, naming a point on the terminal side. Again, we're on the line y equals x, so I'm just going to pick an easy point, even easier than the last one. I'll pick 1, 1. Okay, if I pick 1, 1, I've got 1 squared plus 1 squared, because I have 1 minus 0 is 1, and squared. Just the square root of 2. Okay, that's our distance. That right there is the special right triangle 45, 45, 90 rule you have to remember, like a square root of 2. It's the exact same thing. 90 degrees is a little bit, I don't want to say tricky, because it doesn't always stick right away what angle or what quadrant that angle falls in. It's going to be straight up here. I went 90 degrees. That's still going to be in quadrant 1. We are still in that first quadrant. Okay, once we get to like 90 point something, then we'd be in that second quadrant. Okay, another positive, add 360 to it. That gives me 450 degrees. Negative 270 degrees are coterminal angles. I could keep adding 360 and come up with an infinite number of coterminal angles. To find a point on that side, okay, that's on the line of x equals 0. So x equals 0, y can equal anything else. So I'm just going to pick 0, 5 for my point. I could use my distance formula, but that would look like this, which is the same thing as the square root of 5 squared, which is just 5. Since we're going straight up, we don't even need to use the distance formula. You could just count. Once you start going at an angle, then you have to use your distance formula. So, what did we cover in this lesson, and what things are you still not 100% sure of? This is a great place for you to kind of put things down in one concise location for you to reference back to. The homework assignment is right here. Remember, you don't have to do all of this. Just try a couple of problems. When you come back to in class, then we will work on them together and we can answer questions. Just try a few so that you can kind of see what you feel comfortable with and what you're not so sure about. All right, have a great day.